This lesson is on weathering. Weathering is the process by which rocks are broken down into smaller pieces. There are two types. The first one is physical weathering, which you may also see referred to as mechanical weathering. You just have to know that those are one and the same. Physical weathering, mechanical weathering. Doesn't matter which term is used, it's the same. And then we have chemical weathering. Mechanical or physical weathering is the process where rocks break into smaller pieces with no change in their composition. So there is no chemical reaction and therefore no change in what the rock is made of. The breakdown of the rock is simply, like the name states, it's physical only. It's just a bigger rock being broken down into smaller pieces of rock. Mechanical weathering is going to happen more readily in cool, dry climates that also have dry, loose, sandy soil. The main causes of mechanical weathering include wind, the force of falling or flowing water, temperature fluctuations, tectonic processes, and some types of biological activity. Wind can carry sediments which hit and weather rocks. So the wind can blow already weathered pieces of sediment against rock, and I like to call this nature's sandblasting because that's much what it's like. Okay, like I said, the wind just picks up sand, throws it against rock, and the sand actually knocks off tiny pieces of the rock whenever this happens. All right, flowing or falling water. The force of flowing, falling, or splashing water can physically weather rock. It can weaken the rock and break pieces off. Don't, however, confuse this with chemical weathering that's associated with water. That's totally different. When we're talking about mechanical weathering due to water, we're talking about simply the force of the water striking the rock. All right, temperature fluctuations. We know that when something is heated, it expands, and then when it's cooled, it contracts. And this is also true for rocks. Okay, they can be weakened and weathered by being repeatedly heated up and cooled down. This can happen from season to season. It can also happen between day and night. And this is very common in deserts where it can be very hot during the day and then very cold at night. The rocks are constantly expanding and contracting, and this weakens them and causes pieces to fall off over time. All right, tectonic forces. Rocks located at the plate boundaries can be broken, worn, or melted as rifting, collisions, and or subduction occurs. So all those processes can weather the rock in various ways. Biological activity. Plants and animals can cause mechanical weathering. Plant roots growing into rocks can produce and widen cracks. We've probably all seen that before. We've also probably seen that happen to pavement. Burrowing animals can scratch and move rocks as well. Now also, us human beings, if we do anything to break rock down, say you went outside with a hammer and started beating on a rock and breaking pieces off, that counts as well. It counts as weathering. We often fail to see ourselves as natural things in this world, but we also are. So it counts just like any other form of biological weathering. Now, this is kind of skipping forward to chemical weathering, but animals that die and their bodies are breaking down and they're on top of rock or their remains come in contact with rock, acids that are produced from the decaying of that animal can also contribute to breaking down rocks, but like I say, that's a chemical process, so please don't confuse that with the mechanical biological processes. All right, frost wedging is the repeated freezing and thawing of water in the cracks of rocks. Each time this happens, the crack gets larger. Okay, so you have a crack in rock, it fills with water, right? When the water freezes, it expands. Now, this is counterintuitive. We just got through saying when we heat things, they tend to expand, and then when we cool things, they tend to contract. But Water has this special property where it expands when it freezes. So water flows into the crack in the rock, and then when it freezes, it expands and makes the crack bigger. So the next time water flows into the crack, more water can get into there because the crack is larger. And then when that water freezes, it breaks the crack open even larger. So this happens until it breaks the rock up significantly. A lot of potholes we see in the road happen this way. You might notice sometimes potholes tend to form in areas where there's constant shade and the sunlight doesn't seem to reach that place on the road very often. You don't often see that in the cities, but out in the rural areas you can see that. All right, unloading and exfoliation. Unloading occurs when underground igneous rock becomes exposed at the surface through uplift and erosion. So if tectonic forces cause igneous rock to be exposed at the surface, we refer to that as unloading. Also, if soil layers or other rock layers are removed through weathering and erosion, we would also refer to that as unloading. Exfoliation occurs when pieces of uplifted rock are weathered and chipped away in layers, as you see in the picture below. Oftentimes, when someone's trying to give an example of how exfoliation works, they talk about peeling the layers of an onion. All right, on to chemical weathering now. Chemical weathering is the process where rocks undergo changes in their composition and are thereby weathered. So we're having a chemical reaction that's causing the rock to break down. This is going to happen more readily in warm, wet climates with moist, organic, rich soil. This can be caused by water, oxygen, carbon dioxide, and various acids. All right, hydrolysis is the chemical breakdown of a compound due to a reaction with water. So we have certain minerals that if they react with water, it will cause them to undergo a chemical reaction and break down. And this breaks the rock down. Also, there is oxidation. We more commonly refer to that as rusting. This is a reaction of oxygen with other substances to create new substances. And also this can aid in breaking down rock, especially the metal component of rocks. All right, with hydrolysis, water causes chemical weathering by absorbing gases from the atmosphere and the ground. When water absorbs carbon dioxide, it forms carbonic acid, which is effective at dissolving rocks and the minerals that make up the rocks. Stalactites and stalagmites in caves are an example of it's the result of weathering and erosion deposition associated with hydrolysis. So if you've ever been in a cave before, you notice there's these drippings from the ceiling. So every time the water drops, it's taken a little bit of the minerals from the rocks with it, and it forms these like spikes from the ceiling and spikes from the floor, and eventually with enough hydrolysis and erosion and deposition, you can end up with these columns where they connect like this. So if you ever visit a cave and you see the stalactites and the stalagmites and the columns in the cave, you'll know that now that those are the results of hydrolysis. All right, oxidation. Here's a good example of oxidation. The Statue of Liberty, which is made of copper. All right, we know copper is usually a brownish kind of color. But over time, that brownish color is turned green by chemical weathering associated with water reacting with that copper. The Statue of Liberty now has what we call a patina on it, and it's the result of oxidation of the copper. There's some ornamental pieces that are on some fancier houses, and they're made of copper, and they're purposely intended to oxidize and have that cool looking green color over time. All right, rusting is a form of oxidation in which iron is broken down. So iron combined with oxygen and water equals rust. This is something we've all probably seen before. Most kids, if you ask them about rust, they say that they left their bicycle or something like that outside, and noticed how quickly rust could form. All right, differential weathering is when rocks weather at different rates. All right, some rocks are hardier than others. They don't weather as easily. Some rocks are quite weak, and it's really easy for them to be weathered. In the picture here, you can see that this lower layer, it seems to be some kind of sedimentary rock that is, in the first place made of sediments that are compacted and cemented together, and it's not very strong, so it's weathered really easily compared to what looks like some igneous rock above it that's more hardy and surviving those agents of weathering better than the sedimentary rock is. So differential weathering is caused by different mineral compositions. Some minerals are more susceptible to weathering than others. And then also, like I was saying, sedimentary rocks, they're known for weathering really easily, much easier than igneous or metamorphic rocks do. So not all rocks are going to weather at the same rate. It's going to depend on the mineral composition of the rock, which of the three major rock types that rock is, and it's also going to depend on what environment it's in. You could have the same kind of rock in two different environments, and in one environment it may weather a lot quicker than another environment.